Welcome to 101AI.net, your comprehensive guide to understanding and mastering artificial intelligence and machine learning. In this presentation, we will walk through various essential AI and ML concepts and see how our interactive tools help you learn and apply these concepts effectively. Let's begin our journey into the fascinating world of AI and ML. Let's start with a practical example, predicting house prices. We have a data set containing the size of a house in square feet, the number of bedrooms, and the corresponding price. By training a neural network model on this data, we aim to predict the house price based on its size and number of bedrooms. This example will help you understand the entire process from data preprocessing to model training and prediction. Next, we have another example, predicting car prices. Here, the dataset includes the engine size, horsepower, and price of various cars. Similar to the previous example, we can train a neural network model to predict the price of a car based on its engine size and horsepower. This example reinforces the concepts of data scaling, model training, and prediction in a different context. In this example, we predict student test scores. This is based on the number of hours studied, the number of practice tests taken, and the test score. This example illustrates how machine learning can be applied to educational data to predict outcomes and provide insights for improving student performance. By training a model on this data, we can make informed predictions about future test scores. Returning to the house price example, let's dive deeper into the full process. We start with the training data, which includes the size of the house, the number of bedrooms, and the price. We then pre-process the data by scaling it, which is crucial for effective model training. The scale data is then converted into tensors, which are used to train the neural network model. After training, the model can predict the price of a house based on its size and number of bedrooms. Here, we outline the entire training process for the house price prediction. This process involves several critical steps. First, we start with the training data, which includes the size of the house, the number of bedrooms, and the corresponding price. Next, we scale the data to ensure that it is standardized, making it easier for the model to learn. This standardized data is then converted into tensors, which are the fundamental data structures used in machine learning. Once the data is prepared, we can define the model. In this case, our model architecture includes an input layer, a hidden layer, and an output layer. The model configuration specifies the activation function, the optimizer, loss function, and learning rate. For our house price prediction model, we use the Sigmoid activation function, Stochastic Gradient Descent, or SGD, as the optimizer, mean squared error, or MSE, as the loss function, and we have a learning rate of 0.01. After defining the model, we train it over multiple epochs. During each epoch, the model parameters, including weights and biases, are updated to minimize the loss function. This iterative process helps the model learn from the training data. Finally, after training, the model is ready to make predictions. We input the size and the number of bedrooms of a house into the trained model, and it predicts the house price. Each of these training steps is available on our platform 101AI.net, where you can learn and explore them interactively. You can access various tools that allow you to visualize data scaling, tensor operations, model training, and prediction. By engaging with these tools, you'll gain a deeper understanding of the machine learning workflow and how models are trained to make accurate predictions. Let's take a closer look at the structure of our neural network model. The model consists of an input layer, a hidden layer, and an output layer. Each layer has weights and biases, which can be adjusted during training to minimize the prediction error. Understanding the architecture of a neural network is fundamental to grasping how models learn from data and make predictions. After training, the neural network model's weights and biases are updated to accurately predict house prices. This slide shows the trained model's weights and biases, and we can examine these values to gain insights into how the model has learned from the training data. Understanding the final trained model parameters is crucial for interpreting and validating the model's predictions. Let's see how the prediction flow works in a trained neural network model. We start with input features, which are standardized using the same parameters as during training. Here we have a house with a size of 1,500 square feet and 3 bedrooms. The standardized input is then passed through the neural network to obtain a standardized output. This output is then converted back to the original scale to get the final predicted value. For this example, the predicted price of the house is $373,764. This flowchart illustrates the end-to-end process of making predictions with a trained neural network model, showing each step from input standardization to final output. Now that you've seen how the entire process works, from data scaling and model training to making predictions, I encourage you to start exploring the platform. Let's walk through how to use this interactive tool effectively. At the top of the page, you will find the title, which in this case is Neural Network Perceptron. This title indicates the current topic you are exploring. To the right of the title, there is a navigation button labeled Next Topic. Use this button to move forward to the next lessons in the series. Below the title, you'll see links to videos, notes, and code. These links provide additional resources for you to use. The video link will take you to a tutorial or explanation video. The notes link will provide written explanations and summaries, and the code link shows the source code relevant to the current topic. The main area of the page features the interactive playground. This is where you can engage directly with the concepts. For instance, in the perceptron example, you can adjust the input values, weights, and bias to see how they affect the output. The playground visually represents inputs, weights, the weighted sum, the activation function, and the final output, helping you understand how a perceptron works step by step. You can also navigate directly to different topics and tools using the menu bar at the top. Take your time to explore the 101ai.net platform to interactively learn and practice these concepts using our tools. Click the Start Learning button to begin your journey into AI and ML. Let's dive in and start learning.